Here this question is asking determine A1, A2, and C1 and C0 in terms of B1, B2 so that the two system in figure Q4 are equivalent. If you look at the figure of the first figure, we have B1 and B2. And if you look at the second figure, we have A1, A2, C1, and C0, all these things. So we have to compare these two diagram and see how they are equivalent. Now, in order to do that, first we have to derive the equation from the diagram. If you look at the first one, we can express this h of z in order to express this one, we have to see what is happening for the b1 and b2, and you can see we have a z transform, like one z transform for b1, and b2 we have one z transform. So if we express this one in the equation, it's going to look like this: 1 over 1 minus b1, and the z transform z power minus 1. And then similarly for the b2, same thing: 1 over 1 minus b2 z power minus 1. Now what we have to do is we have to combine them together. So because uh, when we compare with both of them, we had to compare, and I mean we had to combine and bring it into a simple term, like we express it in such a way that everything is together. Okay, so in order to do that, I take the common denominator. In order to take the common denominator, we have to take both of them because both of them are different. So we are going to have 1 minus b1 z power minus 1 multiplied by 1 minus b2 z power minus 1. And if we do that, then in the in the numerator we have to multiply this one by this in this one, and this one by this in this one. If we do that, the equation will become like this: 1 minus b1 plus b2 z power minus 1. Okay, now we have to expand furthermore and simplify this one. So if you do that, then the top part will become, instead of doing that, you can also, like if you want to see it clearly, you can also, like, instead of doing that, you can show the multiplication as well, like 1 times 1 minus b to z minus 1, because we are multiplying this 1 by this term, since we are taking this as a common denominator, plus 1 times 1 minus b1 z minus 1. Okay, and we have to expand the denominator. If we do that, then the denominator becomes 1 minus b1 z power minus 1, and then minus b2 z power minus 1, then b1 b2 z power minus 2. And the numerator, I can simplify this one furthermore. Okay, we are just adding those two together. So 1 plus 1 is going to be 2, and then minus, we have b1 z minus 1 z power minus 1, and then we have b2 z power minus. Okay, so this is what we are having. This is from the diagram, the first diagram. Okay, this equation is from the first diagram. Now the next thing is we have to derive the equation from the second diagram right here. In the second diagram, we have one loop here and another loop here. So if you look at the loop 1, we have a1 and the z power minus 1. And if you look at the loop 2, we have a2 and z power minus 1. These two are x terms, and this term right here is y term. Like how do you know it's xy term? Like, you have to see if you have anything attached with this, there's a y axis, but for this one there's nothing, but for this one we have another one attached, and that one is y. Okay, in that way we know that this is y, and this x of z is nothing but y of z over x of z. h of z is nothing but y of z over h of x of z. So x of z, which is equal to h of z, and that one can be expressed. Here we have, let's look at the loops here. We have a loop one. Before I even write the formula, I can note that one down. Loop one, we have a1 z power minus 1, and loop 2 I have, I'm just looking at the x, a2 z power minus 1. Okay, so the loop gain is going to be multiplication of these two. So that's going to be a1 a2 z power minus 2. Okay, so here what we have to do is we have to use the Mason gain formula. If you use the Mason gain formula, in Mason gain formula, if you have y, we just put it in the top like c0, and then z1 have a 1 z transform, so c1 z power minus 1. So we put it in the like this. C1, the c0 is on top. This doesn't have any transform, but c1 has a z transform, c power minus 1. So c1 z minus 1, and in the denominator we put all the x values. The x values are, first we start from 1 minus, and then a1 z power minus 1 minus a2 z power minus 1, and then the loop gain, which is a1 a2 z power minus 2 plus a1 a2 z power minus 2. Okay, so this is the equation we got from the second diagram. Now what we have to do is we have to compare this one with the diagram we derive here, I mean the equation we derive here. So I'm going to bring this equation, and now we can start comparing. Okay, let's compare. This is from the, for the first diagram, and this is for the second diagram. Now if we compare this one, as you can see, the one without any transform, z transform, is c0, and that one here is 2. So in that way we know that c0 is equal to 2. And if you look at c1, z1 have a c transform of z power minus 1, but here we have two things have a z power minus 1. What we can do is we can take these two common. So if we take these two common, this is going to be like, we have minus b1 z power minus 1 minus b2 z power minus 1. We can also write this one as minus b1 minus b2 all together z power minus 1 as well. Okay, in that way we know that this b1 is nothing but, okay, there's no comma here. Okay, this is a 1, b minus b1 minus b1 minus b2, and that is our c1. And if you compare the denominator, we have a1 z power minus 1, a2 z power minus 1, and others remain the same. So from this one we know that a1 is therefore equal to b1, and a2 is equal to b2, and that one also prove here as well, a1 a2 b1 b2. So we know that a1 is equal to b1, a2 is equal to b2. Okay, and that's all we have to show. We have to show that this is equivalent by comparing these two equations and finding the values for each of them, like c0, c1, A1, A2. And this is our final answer. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.